Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in today's video, we are going to learn about measuring instruments for current and voltage. And here we are going to learn about the galvanometer, ammeter and voltmeter. Okay. Galvanometer, kindly remember that here galvanometer always measures very small amount of current. If large amount of current will flow, then galvanometer may damage also. Okay, that's why galvanometer can be converted into ammeter by connecting a low resistance in a parallel. Similarly, a galvanometer can be connected in a voltmeter also by connecting a high resistance in series. Okay, all these things we will learn in a next chapter, moving charges and magnetism. But in this video, kindly remember that here galvanometer can allow only a small amount of current. Okay students, so let's start the video. So here you can see here there are various instruments like galvanometer, ammeter and voltmeter, which can be used to detect current and voltage depending on the range, as I have told you. Now let's see ammeter. Very familiar. So see here, it is an instrument used to measure current and is always connected in series with the element through which current is to be measured. This element may be resistor, capacitor, inductor, any cell and all that here. Okay, now some points are there. See here, for higher accuracy, resistance of the ammeter should be very small because it is going to be connected in a series, that's why. Second one, an ammeter is said to be ideal. Remember that if its resistance is 0, and 0 means what? Short circuit here. Okay students, so I hope so this ammeter and this basic two conditions are very clear to you. Next one, let's see here the voltmeter. So see here, it is an instrument used to measure potential difference and is always connected in a parallel with the element across which voltage is to be measured. Voltage means potential difference. Okay, now again some important points are there. Let's see here, the first one, for higher accuracy, resistance of the voltmeter should be very high as it is going to be connected in a parallel, that's why. Next one, see here, a voltmeter is said to be ideal if its resistance is infinite. Infinite means here open circuit. Okay, can you see here very well? Is it? Very basic thing is there. You also know a lot of things. Next one here, representation of practical and ideal ammeter. As I have told you very well here, practical ammeter means the resistance will be very small. So let's take here, if anywhere in a circuit this ammeter is given. Okay, so what will happen that here, practical ammeter means what will be there, its resistance, some resistance will be there. Okay, and this ammeter will be replaced by one resistance RA. And remember that here this RA is a very small. Okay, even if I can write, this is the terminal MN. Okay, so wherever ammeter is connected, you will just replace with the resistance of the ammeter. Okay, similarly if we talk about here the next one, let's take here the ideal. Second one here, let's take this one here. Here also M and N. So here what will happen that here, this ammeter will be just replaced by here one short circuit here. Okay, what is this here, students? This is just the short circuit here. Okay, that means we can tell that here resistance of the ammeter, how much here? 0 ohm. Is it? I hope so very clear. This is which ammeter? First one, this is the practical one. This is practical. Okay, practical. Is it? And this one is ideal. This one is ideal. Is it? Similarly, if we talk about here the voltmeter, so here representation of practical and ideal voltmeter. Here what will be there? Remember that here, kindly see. Wherever this voltmeter is connected, let's take for example, I have taken here point JK for example now. So here what will happen that here, this voltmeter will be replaced by the resistance of the voltmeter here. Okay, these are the terminals JK here. And remember that here this resistance is going to be very high in the order of mega ohm and all that here. Okay, and this is the practical one, practical voltmeter here. Okay, similarly if we talk about here the next one, let's take for example here again, this voltmeter is there. Is it? You know very well, have to connect in a parallel only. Okay, then what will happen that here this voltmeter will be just replaced by here the open circuit. Is it? Open circuit means how much resistance here? Open resistance means infinite resistance here. This RV is going to be how much here? Infinite. Is it? And this is which one? This is the ideal. So I hope so. This representation, practical and ideal ammeter and practical and ideal voltmeter is very clear to you. Most of the time, if nothing is mentioned, we will take a ideal ammeter and voltmeter. That means the second representation represented by blue color here. Okay. Now let's take here. See here, one basic question is there. See, the question is, the resistance of a most accurate ammeter can be how much? We know that here the RA should be small. RA should be very small. Then just check the option and tell me here which one is the minimum. 0.15, 0.51 ohm. So you can see very well option A is the answer. Okay, similarly see here, the resistance of most accurate voltmeter can be. Okay, so now we have infinite is there. Now that means ideal is not there. Then that means what we'll choose here? High. So see here, RV should be very high. Okay, ideally infinite, but infinite is not there here. Okay, so very high. See, 1 kilo ohm. Kilo ohm means 10 power 3 ohm. 5 mega ohm means 5 into 10 power 6 ohm. Yes, here this is 5 into 10 to the power 6 ohm. 1 kilo ohm means this is 10 power 3 ohm here. 0.5 mega ohm means 0.5 into 10 power 6 ohm. And 10 kilo ohm means 10 into 10 to the power 3 means 10 power 4 ohm. So when you will check out very well here, which one is the very high resistance? Option B is the very high resistance here. Okay, so resistance of the ammeter is very small, ideally 0. Resistance of the voltmeter should be very high, ideally infinite. Is it? Correct? Next one, to solve the further, we are going to solve the questions further. Okay, so we need little bit basics of voltage divider theorem and current divider theorem. This voltage divider theorem will be used when resistors are connected in series. I have just taken here R1, R2. Okay, this is connected in series to a this supply voltage V. Now let's take here voltage is V1 and here voltage is V2. Is it? So remember that here, according to the voltage divider theorem, this V1, now basic Ohm's law is there. So V1 will become here, remember that here, R1 by R1 plus R2 into total voltage. Similarly, if we talk about here, V2, this V2 will become here, see here, R2 by R1 plus R2 into V. Okay, in this way, we can get here the potential difference across R1 and R2. Okay. Now, if we talk about the current divider theorem, so current divider theorem will be applicable when resistors are connected in a parallel. Let's take here, this is R1 and this is here R2, like this, is it? And let's take for example, here current is coming I, this side current is going I1 and this side current is going I2, and again I current will go ahead. Okay, so here what will happen that here, see, this current I1, now current in resistor R1 is given by, see here, R2 by R1 plus R2 into I. Okay. Similarly, if we talk about here the I2 is given by, remember that here, that means current in resistor R2 means R1 by R1 plus R2 into I. Make sure that I1 means this side R2, I2 means this side R1. That's why the current divider theorem becomes sometimes little bit tough. Okay, so this is that thing. Now we are going to solve here some basic questions to understand all these things. Now, so see here the question is JEE 2015 question. 4 bulbs B1, B2, B3 and B4 of 100 watt each are connected to 220 volt means, as shown in figure, the reading in an ideal ammeter will be how much? See, even they will not tell also, we will consider ideal. So what is this ideal ammeter here? So what we'll do here, ideal ammeter means what will happen that here, resistance of the ammeter is the 0 ohm, it will become here what? Short circuit. Okay, so if I just draw here the equivalent diagram, which diagram here students? Equivalent diagram here. So bulb will be represented by the resistance here. Okay, and here what is this? One ammeter is connected. No? Here one ammeter is this, and this ammeter is represented by what? Short circuit here, is it? And again you can see here one bulb is connected and here one supply is this here. No? Can you see very well here? 220 volt here. Bulb how much is this here? See, bulb B1, see here R1, R2, and identical bulbs are there. Na? Each 100 watt is there. Na? That means we can write here all R. Now this is also R, this is also R, this is also R, this is also R is there. Okay. Now what will happen that here? See here please. The sum current will come from here. No? So what will happen that here? All the this all of them are connected in a parallel, na? And voltage is same, resistance is also same, so identical current will flow. Here also I, here also I, here also I, is it? And here also I. How much current will come from the supply? The current will come from the supply 4I. But remember that if I apply here the KCL, so what will happen that here I is coming, I is coming, I is coming. That means in this ammeter, how much current will come here? 3I current will come. Okay. Now if I ask here what is the value of I, na? Current across one bulb at least, current through one bulb. So we can write here I equal to, you know, P equal to VI. Okay, so I means P by V here, is it? So power how much is given for the bulb? 100. Okay. Voltage how much is given here? 220 volt, is it? So what will happen that here? 0, 0, cancel and just cancel here. 2, 5 jar 10 and this one here 11, 5 by 11 ampere. This is the current in one bulb. But here in a ammeter, ideal ammeter, how much current is flowing? 3I. Okay, that means current in a ammeter is given by 3I. Na? So 3 into 5 by 11. Okay, so what is coming here? 15 by 11. 15 by 11 means we can tell 11 1 11, 1 point. Then after that, when you will simplify this here, very easy, it will come here 1.35 ampere. Which option is correct here? The correct option is here, option C is the answer here. Okay, very simple. Bulbs means represented by the resistors, and all bulbs are identical. Resistance is same, connected in parallel. That means potential difference is also same. That means definitely same current will flow through all the bulbs, and in this ammeter 3I current will flow. Very easily we have done it here. Okay, great. Now let's see the students, this question is there. The question is what? See, in the circuit shown below, the readings of the voltmeters and the ammeters will be how much here? Okay, and these two circuits are there, circuit 1, circuit 2. So nothing is mentioned means which kind of voltmeter and ammeter? Ideal. Okay, so ammeter short circuit, voltmeter open circuit. Let me draw here the, no, I will just draw here this thing here. No, so see here, this is here short circuit, because ammeter is this, no, see here, ammeter is this, and here this will become here the open circuit, because voltmeter is there here. Okay, and like this is there. No? So what is this? This is 10 ohm, this is 10 volt. Okay, and here the current that is flowing here I1, and here the voltage that is what? V1 here. Okay, so you know very well here now when any current will I1 is this, na I1. So here also how much current will start? I1 only. Why? Because when the current will reach here in the voltmeter, current cannot flow because this is open circuit. So I1, is it? So what will become that here? This I1 is given by V by R. Voltage 10, resistance 10. So 10 by 10, what is coming here? 1 ampere. Okay. Similarly, if I ask here, if I see here the V1, this V1 will be how much here? Current is going I1, this is 10. So we can write here IR, I1 into 10. I1 how much here? 1 ampere. So 1 into 10, how much are the students here? 10 volt here. Okay. That means this will measure 1 ampere, and this voltmeter is going to measure 10 volt. I am talking about the ideally. Okay. Now students, if we talk about here the next one, let's check here also. Here also we'll draw here the diagram. Okay. So here what will happen that here? Again, let's see here. This is 10 ohm. Okay. And here also 10 ohm, is it? And here voltmeter is this. This will become here the open circuit. Voltmeter is open circuit. After that here, like this we can draw here. Okay. See here. No? Then after that we can see here. See the students. Here how much current is flowing here? I2. Here also no current will flow through the voltmeter. So here also how much current will flow here? I2. Okay, and this is how much here? 10 volt. Now, so again we can see here in this branch there is the no current here. Now, and here this one we have to measure here. This is the, what is this? V2 here. Now, open circuit. So now what will come here? If I write here the I2 will come here. Again, voltage is V, this resistance is 10. That means we can write here 10 by 10. How much here? 1 ampere here. Okay, no current in this branch, no voltage drop in this resistance 10 ohm. If I talk about here the voltage V2 here, okay. So again what will happen that here there is the no current in this resistor, no voltage drop. That means whatever voltage drop in this 10 ohm resistance, same voltage will be measured by this voltmeter. So V2 will become here what? IR2. Okay, or we can tell here I2 into 10. No? I2 into 10 I can write here. I2 into 10. I2 is coming here and this is 10. So again what is coming here? 10 volt here. So you can see very well I1 is 1 ampere, I2 is also 1 ampere, that means both are equal. V1 is 10 volt, V2 is also 10 volt, that means that is also equal. That means correct option is what here? If you will see here, option D is the correct answer. V1 equal to V2 and I1 equal to I2. Is it? Great. Next one, let's see here students, this question is this asked in a NEET 2012. I have just selected the question that is important and we can understand the concepts. Okay, so see, in the circuit shown, the cells A and B have negligible resistances. For VA equal to 12 volt, R1 is 500 ohm, R is 100 ohm, you can see in the circuit diagram. The galvanometer shows no deflection. The value of VB is how much here? Okay, so in this galvanometer there is the no deflection, that means current through the galvanometer is 0. Okay, even same condition we use in a Wheatstone bridge also. Okay, so what will happen that here? Let's take for example from here, let's take current I is coming here. So current I will come here. Any current is going this side? No, that means here also current I and here also current I. In this there is the no current. This is only possible when this VB, this potential difference across this point and potential difference across these points, both are will become equal here. If I write here AB and let's take right here CD, so potential difference across AB and potential difference across CD when equal, then only current in galvanometer will become 0. Very basic, I told that. Okay, but now if we talk about here the current, how much current will flow here? You know very well, this R1 and R connected in series. Series means current will be same. Here also current I, here also current I. So I can write here I means VA by R plus R1. Okay, VA how much is given here? 12. Okay, R how much is given here? 100 plus R1 is how much is given here? 500. So it will become here 12 by 600. Simplify this, so 12 5 just 60 we know, no? So 1 by 50 ampere. Current I is coming here how much here? 1 by 50 ampere. What they are asking here? The value of a VB. So what I told you here, the VB means the potential difference across AB. No? Or even if you wish, you can take some other points also. I have taken here B dash here. No? So VA B dash here is equal to what we can tell here, potential difference across CD. This potential difference and this potential difference should be equal, then only there is no current in this galvanometer. So VCD, what we can tell here, I into resistance R. I how much here? 1 by 50 into capital R value, how much is given here? 100. Is it? So 100 by 50, how much is coming here? 2 volt. 100 by 50, how much here? 2 volt. Any option is there 2 volt here? Yes, correct option is here. Option B is the answer. Okay, see, NEET 2012 question here. No? And galvanometer anyhow, ideal galvanometer is there. Okay, 0 resistance. Now let's see this question here, students. The question is see, asked in a JEE 2022 exam. The question is see, two identical cells, each of EMF 1.5 volt, are connected in parallel. No? In parallel. Up to this is okay. In parallel. After that, next one see here. Parallel across a parallel combination of two resistors, each of resistance 20 ohm. Now after that, next one, see here, a voltmeter connected in the circuit measures 1.2 volt. The internal resistance of each cell is how much here? Okay, so what is happening that here, if I draw here one basic diagram, so what is this? First here, we have this cells, these two cells are connected in parallel. This is E, this is E, this is R, this is R. Okay, they are connected in parallel and they are connected across resistance, and resistors are also connected in a parallel. How much is given here? It is given here 20 ohm and this is also 20 ohm. And then we have connected one voltmeter also. Here one voltmeter is there. Okay, and this voltmeter is measuring how much here? 1.2 volt. Okay, so this is the situation. So remember that here, if we talk about the cell. So for the cell, what will happen that here, when E and E connected in parallel, equivalent will be also E. And when R and R connected in parallel, you can see this R and this R, it will become how much here? R equivalent will become here R by 2. Okay. Similarly, if we talk about here this capital R equivalent here, now this one here, 20 ohm connected in parallel, 20 by 2, that means how much here? 10 ohm, is it? Now what we'll do here, we'll draw here the equivalent. So when I will draw here the equivalent, it will look like, see the students here, see, this is E now, and here this resistance is, this is how much here? R by 2. E value is how much is given here? 1.5 volt. Okay, E value is 1.5 volt. Remember that here, this E value is 1.5 volt is given here. Okay, now after that, see here this is 20 ohm in a parallel, what is came here? 10 ohm, and here we have 1 voltmeter. and voltmeter means which kind of voltmeter? Ideal voltmeter, is it? That means it will be replaced by the open circuit here, okay? And this is V here, okay? So what will happen that here? Again, the same basic is this is here. If the current I will come here and same current I will go here, because this is the open circuit, is it? That means if I write here the value of I, the value of I will be how much here? E by 10 plus R by 2. What is the value of E? 1.5. So 1.5 by 10 plus R by 2. Is it? This current we have got here. Now after that, what will happen that here? You know very well here. This V equal to I. No? V equal to I. No? This voltage and here voltage will be same. So I into 10. Is it? So let's simplify this here. Voltage, how much is given here? Here the students say 1.2. So see, 1.2 is equal to I10. So 10 into 1.5 means 15 by 10 plus R by 2. Is it? Now again you can simplify this here. Just do the cross multiplication. 1.2 into 10. That means it will become here 12 plus 1.2 in plus 1.2 into R by 2. It will become here 0.6 R is equal to 15 here. Okay, student. So when you will simplify this here, I can write here, see, R equal to 15 minus 12, is it, by 0.6 here. Okay. So 15 minus 12, how much here? 3. 15 minus 12 means 3 by 0.6. That means 30 by 6. How much is coming here? 5 ohm. That means this resistance value, how much here? 5 ohm is there. Okay. Here little bit basics of these cells in a parallel, and this ideal voltmeter is used here. Okay, great. Now let's see one more question is here. Let's go through the question. JEE 2015 question. See, a 10 volt battery with internal resistance 1 ohm and a 15 volt battery with internal resistance 0.6 ohm are connected in parallel to a voltmeter. Now see figure, this is a voltmeter here. The reading in the voltmeter will be how much here? Okay, so where is it here? What will happen that here? This voltmeter is this now. This voltmeter will be removed here. Now this voltage is there. Now I will remove it here. Now, and ideal voltmeter means this will become here the open circuit here. Now this will become here the open circuit, and this voltage we have to measure. Okay. Now what will happen that here? You know very well here. Because of 15 volt, current will flow clockwise. Because of 10 volt, current will flow anti-clockwise. Which cell is stronger? 15 volt cell is stronger. That means current will flow in this direction. I, here also I, and here also this I will flow here. This plus, this minus. Anyhow, this minus, this plus. Okay. So what will happen that here? Even you can use the KVL also. No? So by the KVL, what will happen that here? If I move in this direction, plus minus, current is flowing in this direction. So see here students, if I start with the cell 15, so see here, always second sign, second sign. I will move in this direction, second sign. 15 minus 10, okay, plus 15 minus 10, and here how much is this? 1 into I minus I, and here what will come here students here? Minus 0.6 I is equal to 0. See, 15 minus 10 minus 1 into I, and then minus 0.6 I is equal to 0. So what I will come here students? I will come here 15 minus 10 by, we can tell here, I plus 0.6, so 1 plus 0.6 it will become here. That means we can write here 15 minus 10 means students, 15 minus 10 means 5, is it? 15 minus 10 means 5. 1 plus 0.6 means 1.6 here. Okay. Now after that here, correct? 15 minus 10 and 1.6 here. Okay. So then remove the decimal, it will become here 50 by 16. Cancel out by the 2, so it will become here 25 by 8 ampere. Correct now? Current is flowing. Now after that we have to calculate the reading of this voltmeter. No? So let's take here, for example, current is flowing in this direction. No? Okay, anyhow, let's take here. I have taken this is point A, this is point B. Now this is A, here also A, this is B, here also B. So we have to calculate potential difference across AB. So here again I will start with the VA. So VA, second sign, minus 15, then second sign, plus 0.6 I is equal to VB. We reached at point B. That means what will happen that you see the students here, this VA minus VB will become here 15 minus 0.6 means 6 by 10 into I, and I how much here? 25 by 8. Okay, so even you can simplify also, you can see very well. 5 2 ja 10, 5 5 ja 15, 2 3 ja 6, 2 4 ja 8. So it will become here 15 minus 15 by 8. So 15 minus 15 by 8, when you will simplify this here, it will come less than 15. And remember that here, it will come here 13.1 volt here. Okay, so 13.1 volt which is here, option C is the answer here. Okay students, can you see very well now how much beautiful way we are doing here. Now let's see this question. The question is what we see asked in the NEET 2015. A, B and C are voltmeters of resistance R, 1.5 R and 3 R respectively as shown in figure. When some potential difference is applied between X and Y, the voltmeter readings are VA, VB, VC respectively then. So what I told you, this voltmeter will be replaced by the resistances here. Okay, so if I draw here the equivalent diagram is there, see the students here, this is X, this is how much is given here, first one R. Okay, next one let's see here, B means how much here, 1.5 R, C means how much is there, 3 R here. Okay, like this, and then Y here. Now, so let's take here the students here, this is going to measure how much here, this is going to measure here, A means VA and this is going to be VB and this is going to be VC. You know very well, B and C connected in parallel, that means anyhow VB is going to come VC, definitely, because they are connected in parallel. So now what will happen that here, let's take current I is flowing here, I. Okay, so what is the VA students? Let's see here, VA how much here, VA. So VA will come here from the Ohm's law, I into R here. Okay, now if I talk about here VB, VB means let's take here current divider theorem, here the current is flowing here I1. Okay, so I can write here I1 into how much resistance here, 1.5 R. Now you remember I have taught you current divider theorem. According to current divider theorem, I1 means R2 by R1 plus R2. R2 how much here, see, 3R by R1 plus R2, 1.5 R plus 3R and here into 1.5 R here. Okay, this 1.5 R, this 1.5 R. So what will happen that here, when you will simplify this here, see again this I is there, this I, see here this I, no, this, what is this, I1 is this, no, this I1, we have written this is the I here. Okay, like this. So when you are simplify this, again it will come here IR here. Okay, and what is IR? This IR is the VA. So we can tell here the students this VB is equal to VA. Is it anyhow? What we can tell here, B and C connected in series also, so we can tell here VB equal to VC, is it? So you can see what is coming here, VB equal to VA equal to VC, where is all three equal? Option C. Here we have used the current divider theorem and voltmeter, this voltmeter is replaced by the resistance. They are they will give very big errors because resistance are very small, but depending upon the value of R, because R they have not mentioned, na? So depending upon the value of R, if R is the 1 ohm, then very big errors will come, but if R is 1 mega ohm, 10 mega ohm and all that, na, then it will give very good readings. Error will be very small, because we know voltmeter should be having very high resistances there, is it? Now students, let's see the next one, this question. See, in the following circuit, the resistance of the voltmeter is 10,000 ohm and that of the ammeter is 20 ohm here. Okay, if the reading of the ammeter is 0.1 ampere and that of the voltmeter is 12 volt, then the value of R is how much here? Okay, so first we have to note down the data here. The resistance of the voltmeter, how much is given here? See the students here, 10,000 ohm. Okay, after that here, and that of the ammeter, how much is given here? 20 ohm here. 20 ohm is there. Okay, and reading of the ammeter, this current here, how much current is flowing here? If I talk about here, this IA is going here 0.1 ampere. Now data we have to note down very properly, otherwise error will come. Okay, and that of the voltmeter, it is given here the 12 volt here. Here how much is coming here? This one is given here 12 volt here. Okay, so what they are asking, what is the value of the R? What is the value of R? So remember that here the students here, we can write here V, no? V here, this, let's take the potential difference is V. So what we can write here, V equal to IA into this R and this ammeter in a series. So R plus R here in this across point Mn I am using here, is it? Across point Mn. Now let's see here, V value how much you know here, this volt is 12, so 12 equal to IA, how much is this here students? IA, how much it is measuring? 0.1 ampere here, no? So 0.1 and R plus RA, how much is this here? 20, is it? So let's see, simplify this here, students. 12 by 0.1 is equal to R plus 20. 12 by 0.1 means 120 R plus 20, is it? So R will come watch here. See the students, 120 minus 20, how much is coming here? 100 ohm. Okay, 100 ohm here. This 10,000 ohm, no use in this circuit here. So 100 ohm is where? The correct answer is here, option B is the answer here. Is it? Great, great, great. Now students, let's see the second last question is, the question is here. In the following circuit, the EMF of the cell is 2 volt, you can see very well, and the internal resistance is negligible ideal cell. The resistance of the voltmeter is 80 ohm given here. The reading of the voltmeter is how much here? Okay, so this is the practical voltmeter. Okay, so what will happen that here in this situation, first we have to calculate this equivalent here. Okay, this equivalent will be multiplied with the I, will get the reading here. Okay, so what will happen that you see the students here, this is 20 ohm here, 80 ohm in a parallel. How much here? 80 ohm in parallel, 80 by 2, that means a 40 ohm. Okay, and here what is this here? The cell is here, like this here, is it? So this cell is there, plus minus. So again remember that here, this is the, let's take voltmeter is here. I have taken here V1 and V2, is it? Voltage divider theorem we are just going to use here. Okay, so you know the voltmeter reading is going to be how much here? V1. V1 is given by what I have told you, R1 by R1 plus R2 into V. Put the value. R1 how much is coming here, students here? 40 by 40 plus 20, is it? Into how much here total? 2 here. So simplify this, students, see 40 by 60 into 2. Okay, so it will become here what here? 0 0 cancel. 4 by 6 means 2 by 3 into 2. That means how much is coming here? 4 by 3. 4 by 3, you know very well here, students, 1.33 volt. Which option is correct here? The correct option is here. Option C is the answer. Kindly see here. Is it? If in case it is the ideal voltmeter, then what will happen? In case of ideal means what will happen that here, this will become open circuit, and then reading will come here 80 by 20 plus 80 into 2 here. Okay, remember that here, this will become open circuit, and then instead of 40 we will take here 80, is it? Then that will be the very true value, but here this is coming with the error here. Okay, very clear, is it? Now students, let's move for the last question. The question is what here? See, the question is here. The potential difference across the 100 ohm resistance in the circuit is measured by a voltmeter of 900 ohm. Error is going to give resistance. The percentage error made in the reading is how much here? Okay, so remember that here, for if we talk about here the ideal means what will be there? You know very well here, it will be replaced by the how? Open circuit here. Okay, so ideally what will happen that here, see the students here, see this is 10 ohm, is it? And here this is the 100 ohm here, this will become here open circuit. Okay, and here it is coming here V. Okay, V, this is the V, and I can just draw here. Kindly see the students, see, like this I am drawing here. See, this is the 900 ohm, but here what will be this? This will become here the open circuit. What is becoming? Open circuit, and let's take here, this is the V1 here. Okay, true value, ideal. So you know that here in this 900 ohm there is the no current. So if I apply here, this is the we can tell here V1. So here also what will come here, the students here? V1, is it? So what is the V1? V1 is given here, the students. Kindly see here voltage divider theorem. 100 by 100 plus 10 into V. Correct? 100 by 100 plus 10 into V. So it will become here, kindly see the students here, 10 by 11 V. This is the ideal, 10 by 11 V. Now after that, if we talk about here the practical, what will happen that here? Remember that here 900 ohm and 100 ohm connected in a parallel. So we can write here, see, 1 by Rp equal to 1 by 100 plus 1 by 900. Okay, students, take here the LCM 900. So this will become here the 9 times 9 plus 1, is it? So what this will become here, see here, this Rp will become here 900 by 10. So 0 0 cancel. What is coming here? 90 ohm, is it? 90 ohm. 900 ohm and 100 ohm in a parallel means 90 ohm, because practical means this equivalent we have to calculate. Okay, now students, if I draw here the equivalent here, so see here, this is 10 ohm, and here this will be replaced by here how much here? 90 ohm. Okay, and here this is the V. Okay, and now this reading we are going to calculate here. Okay, and let's take here the students here, this reading I have taken here, let's take for example V1 dash. So what will be the V1 dash? Kindly see the students here, this V1 dash will become here 90 voltage divider 90 by 90 plus 10 into V. So what this will become here? It will become here 9 by 10 V. Okay, here ideal 10 by 11 V, practical 9 by 10 V. But what they are asking here? Error. Okay, so see here, percentage error is given by measured value, means error by true value. So measured value minus true value by true value into 100. So remember that here measured value is how much here, students? Here see V1 dash. So V1 dash minus V1 by V1 into 100 here. Okay. Now students, what will happen that here? Kindly see here, it will become here V1 dash by V1 minus 1 into 100 here. Now V1 dash by V1 minus 1 into 100. Okay. V1 dash, how much is this? 9 by 10, is it? So just so see here, actually space is not there now, so see here, students, I will just do here for you. Okay. So see here, students, here V1 dash by V1 dash how much here? 9 by 10 V. So see here, 9 by 10 V by V1, how much is this? V1 is 10 by 11. So see here, 10 by 11 V minus 1, okay, into 100. Okay. So after that, what will happen that here, students? What will happen that here? Let's see here. So V cancel, 9 by 10, and it will become here 9 by 10 and 11 by 10. See, 9 by 10 into, it will become reverse, 11 by 10 minus 1 into 100 here. Okay. Then this will become here what here? 90 by 99. What will come here, students? 99. 9 into 11, 99. 99 by 100 minus 1 into 100. Is it? So when you will simplify this here, it will become here minus 1. Because minus 1 by 100 into 100, because 99 LCM 99 minus 100 by 100. So minus 1 by 100 into 100. So what is coming here? Minus 1%. Negative sign indicates that, you can see very well, negative sign indicates that V1 dash is less than V1 here. Okay, so minus 1% where you can see very well here. Option C is the answer here. Kindly see very well here. Okay. So students, I hope so. This video of measuring instruments you have understood very well. Keep studying.